Okay, and one more video here.
Imagine being able to build anything just by thinking about it. Deep base 44.
They about standard deviation.
Okay, sounds okay. Again, around the mean, close to the mean, far from each data point. But standard deviation is a kind of index to evaluate how far from the mean, Okay.
Let's say you measure the age of a small group. Standard deviation is how much the data scatters around the mean. So first we need to calculate the mean. We get the mean simply by summing the age.
Okay, I think in the past years you already learned how to calculate the mean. I say the average to add all individual number. For example, the height of 1, 2, 3, 4, 5, 6, 6 person, their heights, add them together and divided by 6 by the total number of sample number of it. Thus, it's called sample mean, sample average. And now we know the first person is over the average. The second and third person and fifth person are below the average. And the number 4, number 6, those two persons is they are a little bit over the average. But we have an index scientific term to describe this kind of situation? Yes, that is called standard deviation. I believe me, it's very I can say hard. It's not easy to understand the concept. That's why I prefer to spend 10 minutes to explain the concept again. Okay, let's go on.
Individual and dividing it by the number of individuals. Let's say we get the mean value of 155. Now we want to know how much each person deviates from the mean. If we look at the first person who deviates 18 centimeters from the mean value. The second person deviates 8 centimeters from the mean value, and so on. Finally, person number 6 deviates 6 centimeters from the mean value.
Okay, again, okay. The first person, the tall guy or tall lady, okay, is 18 centimeter over the average, and the second that is 8 centimeter below the average. The third one 15 centimeter below the average. And we can describe this kind of situation. Do you remember last week we calculated the x minus the average? The same way, that is 18, and that would be minus 8 centimeter minus 15 centimeter positive 8 centimeter minus 9 centimeter and 6 centimeter positive. Similar concept, okay? Okay, let's move on.
People said people that are very small or very tall deviate more from the mean value. Now, of course, we're not interested in the deviation of each individual person from the mean value, but we want to know how much the person deviates from the mean value on average. How much do these persons on average deviate from the mean value? This is the standard deviation process. In our example, average deviation from the mean value is 12.6 centimeters. And now, of course, the next question is how to calculate the standard deviation. You can calculate the standard deviation
Okay, I have a question. Who is not afraid of this equation? You are not. Okay, great, great. But I think you are the exception. Okay, okay. I think most people, including me, many years ago. Okay, when I first one is called sigma, the lowercase sigma, and a square root symbol, and 1/n. And here I start from 8, ended with n. And a big sigma, it means sum, to sum all information here. Actually, last week we did a similar calculation. Maybe you don't know, but don't be scared by this kind of formula. Don't be scared. And later, actually, if you have chance, later I will again, as I promised, I will show you how to, for example, I have 50 numbers. How can I calculate mean just a few clicks? How can I calculate the standard deviation in few clicks? You will see me how do I do this, and you can follow my steps. But the most important thing is try to realize why early, maybe 100 or 200 years ago, why those scientists they created those formula. After now, we know it's AI era, it's a digital information era. How can we continue to use it for our knowledge and for earning money from us, right? Okay.
Sigma is the standard deviation, and it's the number of persons. I is the size of one single person. Hash is the mean value of all. The standard deviation is the root of the sum of square deviations.
Okay, I like this screen. Okay, root. Why it take a root, square root of it? Why? Who can tell me why? I don't know, because the scientists who created the rules. I know. Because because to cancel the square here, to cancel the square value, it use a square root symbol. Is it reasonable? Again, recall what we learned last week. I said there could be a square value. Don't ask me why, because that's my next question. Square value is not a real value. We need to take a square root to cancel the effect from the square. Do you agree with me? Is it okay? And now you may ask, it's time to ask why it make it a squared value. Why? 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 Very simple. Sorry. Test. Okay. Very simple. Because imagine that there were 6 persons as 2 minutes ago the video. 6 persons, their height minus the average height, and the result can be positive, can be negative. If we add the sigma, add them together, what we will get? Zero. Because some of them higher than the average, some of them below the average, but the differences, I mean the high minus the average, the average, that sum them together, we will get zero. But it makes no sense. We significantly we can see some are higher than the average, some are below the average. But when you add those differences together, we get zero. It makes no sense. Thus, try to get the difference, one difference, and square it. Second difference, square it. Third, fourth, fifth, sixth, square it. Then added those squared values together. Then we have, according to this case, we have six. So in Taiwan, 6, we have this gesture. How about in your country? 6? We have 1, 2, 3, 4, 5, 6, 7. I have no, because I have no idea, baby. You 6? In Taiwan, 6 it means 6. The same way, you in Philippines, in this, in our gesture, this one. Okay, I learned it. Thank you. But in Taiwan, 6. What's your number? 6. I don't know why. Maybe in our character, 6. Okay. It's a kind of a cultural interaction. Okay, and okay, now it's a critical step here. If we calculate 6 as the population, the denominator, the n, should be 6. But we think those 6 were selected from a big group. Then when we calculate the standard deviation, sure, sigma means the population deviation, standard deviation. But if we use small case, lowercase s, that is a simple standard deviation. And here, the denominator, not n. Instead, it would be n minus 1. Is it okay? I will remind this many times until you can remember this way. Okay, let's move on. And so, okay, this kind of sigma, standard deviation of population, root to cancel the square value, sum to add them together, square the deviation. Why squared? Because try to make all values become positive or 0. Then the scientists created this way. Square it, then add them together and divide it by the number, maybe n minus 1. Then take a square root, then get the index. Is okay? Okay, let's move on.
Divided by the number of elements. For our example, this means that we calculate I.
Yep, okay. Again. The height 173 centimeter for the first total guy, minus the average 155 centimeter, the same way as this line, and we can get the difference. Difference is 18 centimeter positive. The second one, 147 centimeter, the height minus 155, thus that would be minus 8. Minus 8, that is a negative value. Now we try to make it square. Make square. Then the value becomes positive, but the value becomes squared and positive. The same way, add the third, fourth, fifth, and sixth, all them together. Then if only 6 people here, we divide it by 6. But if there are 100 people in a school or in a community or in a building, then we consider those 6 are selected from the 100, select samples. For example, from the campaign, president campaign, we want to select fewer samples to predict the whole population. Under this situation, we will use the denominator minus 1, 6 minus 1. But this time, we can know the professor here, she used 1, 2, 3, 4, 5, 6, and she just wants to know the 6th number is whole population. Okay, if those 6 are selected from a campus, and she planned to calculate, to predict the standard deviation from the whole campus, then here should be 6 minus 1. I think in a few next 1, 2, 3, 4 next weeks we can calculate again. Okay, let's move on.
Minus me and square that. Decide the second person minus me and then square that, and so on until we arrive at the last step. And we divide this number by the number of people. So 6 and take the root of it. The result is then 12.06 centimeters. Each individual person has some deviation from the mean, but on average, the people deviate 12.06 centimeters from the mean, which is now our
And now, after the calculation, the professor got the value that is 12.06. Again, 12.06. Sorry, the screen maybe is too small here. What does it mean? What does it mean? And the range here, 12 above the average 12 centimeters and below the average 12 centimeters. And this range, theoretically, this range from minus 12 centimeter plus 12 centimeter, and their height should be covered 65 or 68% should be here. And we know the first total guy is maybe it's a skirt. Okay, she is out of the range. She is not falling into the 68% of this range. Is it okay? Sure. I will explain this maybe this week, maybe next week. Okay, let's move on. Again, just a reminder. We have 6 numbers. Maybe they are 6. Maybe there is a number of the population. Maybe there is a number of samples, and calculate the mean. Add them together, divided by the number. Now it's 6. Get the mean. Mean is on the y-axis, and calculate the differences: 18, 8, 15, 8, 9, and 6 centimeters. And the mean is 155 centimeters. And now calculate the standard deviation, and got the number is 12.06 from the mean, plus 12 minus 12. This range is called plus minus 1 standard deviation. And sure, if we calculate one more distance here, minus 2 standard deviation and plus 2 standard deviation, it will cover 95% of the samples or population. Is it okay? Okay, let's finish this video. Sorry. Sorry.
But for the average deviation, I would actually just add up all deviations and divide it by the number of participants. Just like we calculate the mean value, right? You're absolutely right. But there are different mean values. In the case of the standard deviation, it's not the arithmetic mean which is used, but the quadratic mean. Arithmetic mean would be used, the result would be 0 every time. So far so good, but now there's one more thing to consider. There are 2 slightly different formulas for the standard deviation.
Slightly different. Where is the difference? Denominator, n minus 1. The symbol, lowercase and italic s for sample, sigma for population.
In the first formula, there is a deviation by n, and in the other one, there is a deviation by n minus 1. But why that? Why are there 2 different formulas? Usually you want to know the standard deviation of the whole population. For example, you want to know the standard deviation of all American professional soccer players. Now, if you had to take all American soccer players, you would take this equation, 1 divided by n. However, it is usually not possible to investigate the entire population. So you take a sample. Then you use this sample to estimate the standard deviation of the population. In that case, you use this one. Therefore, when
Okay, just a reminder again. Population, the denominator n is n. For the sample, for example, 1, 2, 3, 4, 5, 6, those 6 people are selected from the whole population. And to calculate the sample standard deviation, and here should be minus 1. Should be minus 1. Why? Don't ask me why. I studied the relative references, but I still cannot understand why. So don't ask me why. To be honest, I don't. It's very hard to understand, but easy to calculate. Very easy. Trust me, very easy. Okay. Again, why we do this? Because we don't have enough money. We don't have enough time to run the whole population. Thus, we just simply pick up some of them. Then after sample, we calculate the standard deviation and try to use the sample standard deviation to predict the population standard deviation. Okay, let's move.
However, you have data of the whole population and you want to calculate the standard deviation for just this data, you use 1 divided by n. Therefore, whenever you have data of the whole population and you want to calculate the standard deviation for data, you use 1 divided by n. If you only have one sample and you want to estimate the standard deviation, n minus 1. To keep it simple, if the study doesn't cover the whole population, you always use the formula on the right side. Likewise, if you have conducted a clinical study, for example, then you also use the formula on the right side to compare the population. Let's look at the next question now. What is the difference between the standard deviation and the variance?
Okay, what's the difference between variance and standard deviation? Okay, last week I explained this. Now let's watch the professor's explanation.
We now know the standard deviation is the average of one mean. Variance now is the square of
Okay, the standard deviation is the average distance. Okay. Standard deviation is the average distance from the mean. As we watch 18 centimeter, 15 centimeter away from the average, below or higher the average. But the variance is the squared value of it. Generally speaking, variance with low frequency to use, and standard deviation with higher frequency to use. So if you cannot memorize all the details, just memorize this one. Standard deviation, because it's very close to the real distance. Again, put them together. Sorry. Do you find some mistake from the formula? A significant mistake. Square? Not square. The denominator. N minus 1. N minus 1. Very significant. Okay, let's move.
have one and the same formula. The only difference is that in order to calculate the standard deviation, in order to calculate the variance, we don't use it. Other way around, the variance is the squared standard deviation. Standard deviation is the unit of the variance. However, this squaring results in a figure like since the unit of the calculated variance does not correspond to the original data. For this reason, it is advisable to always use the standard deviation to describe a sample. It makes visualization a lot easier. The standard deviation is always in the same unit as the original data. In our example, this would be centimeters. And finally, a further additive data. You want to calculate standard deviation, you can easily do it online with data. Just visit dataset.net, put your data into the table, select the variable you
Okay, let's come back to our video. Okay, then okay, and now I try to show you how to do that in a few seconds. Chapter number 3. Okay, now for example, okay, here, how about, okay, the time in 1 of 50 seconds between successive pulses around the new nerve fiber. Okay, the given example, this one, time between successive pulses, and use technology to find the mean and standard deviation. Okay, let me show you how to do this. Okay, you can follow my steps, and again, have your Google Drive. Go to your Drive. Okay, sure. If you got lost, please let me know. And have a new Google Sheet, or you can call it Google Spreadsheet or Google Excel. Either one is okay. And today, sorry, I will postpone the break time. Then I can move here. Homework question 14. Test. Okay. Homework exercise 3.2.1. Three point two point one. That is the question 14. Question 14. Okay. Get it? Sure. Let me know. Oh, sorry. I may use 5 more minutes to explain this. Sure. No problem. I have plenty of time. Don't worry. Okay. No, sure. Let me know. How to pick what? Oh no. Okay. Is it? Have I again? Okay, sorry, let me shift the control. Okay, shift the control. It's it's very special in Chinese characters. It's full. Okay, I don't know how to explain it in English, but next time shift the space, shift the space. Okay, pick up the information from homework question 14, copy the number here. Can I move on? Okay, sure. Yep. Final question? Okay. The first a little bit down and here, or class here, and the first move to chapter 3.2 and check the question number 14. Sorry again, maybe I will postpone a little bit of time. And select the information from homework, scroll down, go to the question number 14. Select the whole table, then copy to your Google Drive. Yeah, by the way, I heard about the computer setting, one of the default language, English. Maybe next time you can try to find how to switch the language to English. Can I move on? Okay. And now, okay, be concentrate. Just a few minutes. Watch here. Personally, select. I would like this. I type mean, or you can say average. And here, the value here is just after the computer's calculation, and I type mean, it says the next value will be mean of average. Click here, it becomes the blue frame, then move here, click here, and you can select insert function or function. Sure, for example, your computer can be reset every time, but when we move to or, you can select average. Or average. Again, click this cell and move to insert and function or average. Sure. Sorry. Is that okay? Then I click average. Then select a range. The space here, select range from 0.5, hold the mouse key until 14, the last cell.
The 0. Are you sure it's 0.5, not 10.5? It's 10.5.
10.5?
Yeah, I think.
Oh, let me check. Let me check. Sorry. What happened here? Oh, okay. So sorry. I think I need to select again. Maybe I missed Control C. Okay, thank you for the reminder. Okay, then okay, let me do it again. Click here, move to insert and function or average. Then select a range. Okay, and the average should be 8.88. Is it okay? Okay. So use this one. You can get the average in a few clicks, right? Okay. Then the next one. Okay, 5 more minutes. Okay. Standard deviation. I prefer to use the abbreviation SD. And I have a question. I can click here, then click here, and click insert. Insert function and O. Okay, now it's key concept here. ST, standard deviation, ST. Scroll down to ST. And my question is standard deviation. And what's the next? T, standard deviation of an entire population. Next, standard deviation. Pardon me. And next, standard deviation of sample text as 0. Standard deviation of entire population. Standard deviation of entire population text as 0. Okay, which one you prefer to use? Which one you prefer to use? Let's go back to our question. Let's go back. My question is question number 14. The maybe 20 or 30 numbers, they are sampling values or they are the population samples. My question is here. Okay, let's move to here. The time between successive pulses along nerve fiber are given example here. Okay, my question, do you think that are the population value or they are sampling value? Either one. Yeah, I agree with you. They are sampling. Thus, we will use denominator n or n minus 1. N minus 1. Okay, let's move back to our Excel. We consider that is okay, we consider that is samples, not a population. Okay, then click here and click here. Then click insert function. Hi, $1. I found something interesting. Statistic. Oh, sure, you can use it here. Either one is okay. Here is also okay. Then scroll down to standard deviation. Entire population. No. Entire population. No. Okay. Samples. Standard deviation. It didn't say anything, but the .s, I mean, it's for samples. But here, standard deviation of samples. I agree with this one. Okay, and click here. Just one click. Then select a range from 10.5 to 14. Then it shows your selection is from A6 to J10. Looks okay. And click enter, you got the answer. The answer is 6.1. No? 7? Why? 7.1? What's wrong with my computer? 7.30? 30? Okay, let me check what's wrong with my computer. Oh, sorry. 7.13 is here. And here is autofill. I'm sorry. Autofill, no. Suggest no. You don't need to suggest me. The computer doesn't need to suggest me. Okay, so click here. 7.1. Sorry. Here. Okay. Last minute, then we can get a break here. Okay. Do you remember last week we calculate the weight of 605 cakes? We need to calculate one by one. But after we use the software, copy and paste, select a range, and use the function to find the average, find the standard deviation. Few clicks. If you are familiar with the operations, you can get the answer in 10 minutes, right? But it doesn't mean anything, because you can do that even primary school or elementary school student can do it. Now we learn statistics because we want to know the principles, the real rules of this one, not only few clicks. Is it okay? Okay, have 10-minute break. Sorry, I postponed the time. My watch now is 15:17. We can come back about 27 minutes. Okay, see you later, gentlemen and ladies.